Hello everyone. Today I want to talk about some comparison of post-tensioning and ordinary reinforcement of concrete in concrete structures, and also some technical and practical notes for post-tensioning design and application in our design. First, I want to show a very famous graph about comparison of post-tensioning and reinforcement in concrete slabs. It is just comparing cost versus span in slabs, and it says that for slabs under 7 meter, almost 7 to 7.5 meter, 7.5 meter, under that area, under that length, post tensioning is not effective in general, but over that it is a very effective and optimized solution. So if you have, it is general, and you know that post tensioning is applied in big construction works, and when the space is very critical, when the concrete and especially reinforcement is very critical, we try to apply post tensioning to reduce the thickness of slab, reduce the volume of reinforcement, and finally, and have bigger span, bigger clear span and bigger clear height of between the floor and roof. But here you see that here for over 7 meter it is very effective way, but for under 7 meter span it is not good idea to use post tensioning. There are some notes in post tensioning in when you're designing, because post tensioning just especially when you deal with big and thick slabs, you need to follow some design notes in designing, in putting in analysis software, and also in drafting. Also, we put the end of the tendon, or just doesn't matter, live end or dead end, in the middle of the slab. Just be careful if you have change in the thickness of slab. You try to avoid any clashing of the tendon with the edge of slab, and you need to have the minimum cover. That is sometimes very hard to use that, or hard to adjust that. Yeah, it is very tricky point in designing, but anyway, you always put the end in middle of the slab. Another trick, or just say some note that we always need to consider in our post tensioning design, especially when we have, let's say we have a building that has long span and short span like this. Let's say we have this columns here, they have support, and this is the span, and it's critical that deflection is critical. Always trying to control the short length. Here we have long length here and short length here. Always trying to control the short length is more effective than putting tendon in long span. So it means that here, if you have deflection here, if you try to push this part up by tendons, is more effective than pushing in long direction. So you put the main tendons in short slab, like up, down, up, and for the long direction, just go for straight in the middle, or sometimes if it helps, go for just some lowering in the middle to push the slab up. So always remember, shorter span is more effective, shorter length is more effective to put tendons, especially for deflection control. So another one here, just seeing post tensioning, especially in drafting, we have number of tendon numbering, and also we have here, it is very small, but anyway, you can see that you have number of strands in each tendon here. It shouldn't be. We don't need to have the same amount of strands in any tendon, and also we don't need to have the equal distance between tendons along the slab. Just try to adjust whatever you need and what's the best arrangement, but always try not to have less than half a meter in span in slab, and just let's say 300, 400 in beams, because in beams you have more congested area and you can put more because of the thickness of the beam. But anyway, you don't need to follow the same number of strands in each tendon and the same spacing. Just try whatever makes your slab much better in terms of balance load, the slab thickness, and deflection control. Here it is just general arrangement. We have two-way tendons. These are beams, very congested, and these are slabs. Just always try to have the best arrangement. The other note in post-tensioning, just always try to have less than, if you have a very big area to extend the tendon, try to keep it under 30 meter. And in that case, if you have, let's say, about above 20 meter length of tendon, try to have two live ends, because it is very hard to achieve the most optimized tendon performance for just one end for over 20 meter, 30 meters. So always try to have two live ends for jacking and post-tensioning the tendon. And always try to cut it around 30 meter. I can say that from my practice, from my experience, 30 meter is the longest tendon you can have it. You still have some performance, but it's not optimized. So if you have very long, you just cut it in 30 meter and just extend it again. And another one, just it is mainly for beginners. Just before starting arrangement of tendons, try to find the joints in the building. We have different types of joints. It is construction joint, cold joints, saw cut joints, and different types of joints. Always try to find the construction joint and make sure that you're not crossing tendon over the joint, especially for construction joints, construction and expansion joint. Okay, here we may have some joints. Try to not cross over the joints and always be careful about the joints. Another note is just as you don't need to have always tendon in straight direction. You may have some changes in direction. Let's say this is, let's say here, we have a tendon and you don't need to have straight all the way. Sometimes if you have any barrier around, you can just have some changes, but it is reducing the efficiency. But anyway, if you have to, you can change the direction to some extent. But remember, you can't go for big angles. And another one, it just, as I said, you can have adjacent tendons with different number of strands. And also, the very critical point in post-tensioning is balance load. After all, one of the checkpoints for balance load, you know that whatever, if you put more tendons, it is more efficient for your slab design. But remember, more post-tensioning means that you put more load on the concrete part. We call it balance load. For normal concrete slabs, that's around 200. We say that always keep to stay on the balance load between 1 and 2 MPa. But for thicker slabs, sometimes we have slabs around 1 meter or even more. In that cases, you can go, my experience says that you can go up to 3-4 MPa for balance load. But for normal structures, for normal slabs, always, my suggestion is always stay around 1 to 2 MPa for balance load. And another one that is very tricky point, it is sometimes, it is not, that technically wrong, but for construction it is very bad point if you put live end into the core hole. You don't have access to that. Try always, if you have to just put some tendons here, always put dead end, no jacking. So put And always remember, don't put any live end around this core hole box. And another note I can say that here, try to not pass tendon under the columns if you can. And also, what I can say, for the tendons, yeah, tendons are just biggest always is just deflection. And you know that the tendons application is mainly for deflection control. If you have big spans, let's say 10-15 meter spans, it is hard to deflect because the concrete weight is already big. And concrete, I mean that the weight and pressure due to concrete self weight is huge. And one way to control deflection is to increase the slab thickness, but at the same time it applies the load. And sometimes, yeah, most of the time for big spans, yeah, post tensioning is the best way. But remember, you need to stay on the balance load in the range of under 2 in general. It is very critical point that's missed in most of the design works, and it is very critical, and it crashes concrete, and it is very bad design if you go over 2 MPa balance load in normal concrete slabs. And another one, just here, so most of the time in construction we have big voids, void for lightning, void for anything, and just it is very obvious. But anyway, try to avoid crossing tendon in over the voids. And also, if you have very small area, let's say under 7 meter, under 10 meter, just as much as possible, you try to avoid any tendoning in this direction. Let's say my suggestion is under 7 meter. If you have any, yeah, just avoid any tendoning here and put tendons on the long direction to have efficiency to control the deflection. So these are very. And the last point here, just before I forget, you know that post tensioning is very effective way to reduce the volume of reinforcement that is very expensive. And in general, it is reducing the reinforcement to 1/3 to half the normal slab. It is very huge saving, but anyway, it should be designed and checked carefully. Thanks so much.